Tessellations by Willie and Andrew.
Introduction. Tessellations is a repeating pattern of figures that completely cover a plane, without gaps or overlaps. You can make tessellation with transitions, rotations, and reflections. They are important in art and culture, as well as in geometry and higher degrees of mathematics. M.C. Escher. One example of an artist who has worked with tessellation as a form of art is M.C. Escher, who used tessellations to portray real shapes. A tessellation is basically a quadrilateral which has parts cut out of one side and pasted on the other side of the shape.
This is a quick example of some of his work.
The tile pattern above is found in Alabama in Spain, a fine example of tessellation in Islamic art. This museum in France, named the Louvre, uses triangles to make a glass pyramid with a full gallery of exhibits underneath.
A regular tessellation is a pattern made by a regular polygon. There are only 3 regular tessellations, as there are 3 polygons: triangles, squares, and hexagons. Now you see below here, you see this value right here? This will help explain that a little bit better. Now if 3 hexagons meet at this vertex and a hexagon has 6 sides, right here, this is called a 6.6.6 tessellation. That's just one example. A figure does not have to be a regular polygon to tessellate. Every triangle and every quadrilateral tessellates as the figures below show. As you can also see, some of the angles are also congruent when this occurs. Semi-regular tessellations, there are only 8 of them. They have very different values than the ones we have seen earlier. The pattern at each vertex must be the same. So like right here, this pattern has to keep repeating over and over and over. There are dimmer regular tessellations, but mathematics disagree on what they actually are. These are some of the ones most seen in artwork, such as M.C. Escher's stuff, and it's still a debatable subject. Okay, the figure in a tessellation does not overlap or leave gaps. If the figures are polygons, the sum of the measures of the angles are around the vertex in the tessellation must be 360. So here you see that adds up 360. Not a tessellation. So here that gap means that no matter how I move this, it will not be a tessellation. Now here we have this. Now this is an example of no matter how I move it around, it's still if I was to measure these, it would still add up to 360. Okay, here we go. Every tessellation has at least one type of symmetry. The one we're going to focus on is this one. In glide reflectional symmetry, a glide reflection maps the tessellation onto itself. So you see here the motion in the shapes as it maps itself out. That's going to be one that we'll focus on later on. Now, how do you recognize a transformation? What is the repeating figure in this tessellation? What transformation does the tessellation use? Tessellations use very interesting methods of copying itself out, different transformations. Here we see that these shapes right here form a repeating figure. This repeating figure then uses a transformation that we've seen before to repeat itself throughout this whole picture. Now, when trying to figure out if different figures can tessellate, you have to use this formula right here. A equals 180 parentheses n minus 2 over n, where here's a quick example of this. N equals to number, so let A equal the measure of one angle of a regular 18gon. Substitute 18 for n and simplify. So here we just go ahead and go through the math, and this is what we're going to be doing here. If we get down here, we have to figure out if there's the number that we get at the very end. 18 will go in here as the number of sides, by the way. If the number that we get in the end can be multiplied or divided up or down to 360, then it can be tessellated. Okay, so an example problem right here is that this is a figure with 5 sides, okay? Quickly, if you would, take out a piece of paper and try to do the formula we just did. If you have to rewind the video, that's okay. Here we have some final example problems. Does the picture show tessellation of a repeating figure? If so, identify the repeating figure and the transformation used. Now 9, we can see that even though there are shapes that appear similar, there's no repeating figure here. This will be our example. There's no repeating figure. As if we scroll down, we'll see that. For 11, if you would quickly pause your video and try to work this one out. Okay, answer for number 11 is yes. A square composed of 2 white rectangles, 1 small black rectangle, and the 1 large black square. What it uses is translation. So we see that here as well. Okay, that'll conclude our video for section 7. Thank you all for watching and have a good day.